Now let us look into the next property, very important property, which is called as the symmetry of the real sequence. So symmetry property, let us consider. So it's a symmetry of real sequence. So this is one of the property where we can use it to find out the missed DFT pairs. We can use it to find out by using this symmetry property. So it says like this: if the sequence x of n is so the symmetry property will say like this: if the sequence x of n is a real sequence, with the DFT, so the DFT of x of n, so then which is equal to the x of k, then its DFT is going to satisfy the property which is called as symmetry. That is x of k is equal to the, so it's a x conjugate of n minus k, x conjugate of n minus k. So where k can take the value from 0 to the n minus 1. So this is the very important property which is called as the symmetry of the real sequence. Let us prove this one. So in order to consider the proof of this one, let us consider here. So proof, in order to prove this one, we'll consider the DFT formula. That is the DFT of x of n. We'll consider the DFT of x of n. So this is equal to the x of k. So which we have summation n is equal to 0 to n minus 1 x of n into omega n to the power of kn. So since we want conjugate here, we want to conjugate in this one. So what we'll do is, let us take conjugate on both the sides. So take conjugate on both the sides. On both the sides, we'll take the conjugate here so that we can able to obtain the conjugate. We can able to obtain the conjugate. So let us take the conjugate on both the sides. So when you take the conjugate here, so it will become x conjugate of k. So the real sequence does not have any effect on conjugate. So since x of n is a real sequence, even if you take the conjugate on x of n, it will remain same thing only. When I take the conjugate of omega into the power of kn, it will become omega into the power of minus kn. Now for this one, if nothing is there, means 1 will be there. So and also we know that 1 is equal to, so omega n to the power of n into n, which will be equal to the 1 here. Omega n to the power of n into n, which is equal to 1. Let us substitute this one so that we can able to obtain the n minus k we can able to obtain here. So what we'll do is, so x conjugate of k is there on the LHS part. On the RHS part, summation n is equal to 0 to n minus 1. The conjugate, since x of n is a real sequence, so omega n to the power of minus k into n into omega n to the power of n into n will get here. So let us take n common in the Twiddle factor. So if you take the n common, we'll get n minus 1 x of n into, so it's omega n to the power of, when I take n common, the remaining terms are nothing but n minus k into n minus k into n. So we got, this is the, let us rewrite the terms. X conjugate of k is equal to the, so what are the terms we got is, so it is summation n is equal to 0 to the n minus 1 x of n into omega into the power of n minus k into n. Now in order to write this DFT, what we'll consider is, I'm go back to the DFT formula, the basic DFT formula. Let us have some clarity here. So here the DFT of x of n is there, means that the x of n is the input sequence. That's why x of n is came here. The corresponding output will be the capital X, and k is the frequency domain content. The summation n is going to vary from 0 to n minus 1 omega n, and k, whatever the k will be there, that k is going to be reflected in the sequence x of k here. And this n is a time domain content and k is a frequency domain content. So we can write that one as the DFT of x of n can be written as x into the frequency domain quantity, which is called k. So similar way, what we can do here is, so here the x is the input is there, the corresponding output will be the, here also the formula is going to vary from 0 to the n minus 1, and the x is the input, the corresponding output will be the capital X here, and here n minus k is the frequency domain content, so we can write as n minus k, we can write here. So let us recall, x conjugate of k is equal to the x of n minus k we can write, If you take the conjugate on both the sides, so if you take the conjugate on both the sides, so this will become x of k is equal to x conjugate of n minus k we will get here, or else this can also be written as x of x conjugate of, because from the symmetry, that is the time reflection we are seeing, so this can also be written as x conjugate of minus k mod n. So what is the advantage of this property is that, so I'm going to consider this one x of k and x conjugate of n minus k. So what the advantage of this property is, suppose if I know the DFT of the sequence, I know, for example, n is equal to 8, I will take, so where k can take the value from 0, 1, 2, 3, 4, 5, 6, and 7. So at the location k is equal to the n by 2. So at the location k is equal to the n by 2. So it is 8 by 2 will be it is 4. This is the location. The corresponding sequences will play the symmetry here. For example, if I substitute, so I write the formula. So x of k is equal to x conjugate of 8 minus k. So if I substitute k is equal to 5 here, so it will become x of 5 will become equal to the x conjugate of 8 minus 5, which will be equal to the x conjugate of 3. Means that if I know the x of 3 and if I take the conjugate of this one, we can able to obtain the x of 5. So similarly, if 2 is there, if I take the conjugate of x of 2, I can able to obtain the x of 6. So similarly, if the 1 is there, if I take the conjugate of this one, we can able to obtain this one here. So this is x of 1 is equal to the x conjugate of 7. X of 1 is equal to x conjugate of 7. So this one we can write as that is x of 6 is equal to the, so x conjugate of 2, and this one it is nothing but this one we can write as x of 5 is equal to the x conjugate of 3. So if I know the half of the sample values of the x of k, the remaining half we can find out by using the conjugate symmetry or the symmetry property. That's the advantage of this one. So for this one, the sequence x of n should be the real sequence should be there, and so that we can able to obtain the corresponding terms we can able to obtain. This is called as the symmetry of the real sequences, and this property will be helpful to find out the DFT of the unknown sequences, where we know the first half of the samples and remaining half we can find out like this. And also it will be easy for us to identify, after finding the DFT of any sequences, whether whatever the DFT we have find is correct or not. So in order to identify this one, so this property will